So let's look at the next for iterator from JavaDoc. Returns the next element in the list and advance the cursor position. So now we have to modify this because this is only return, right? So this is going to be temp. So we have to say e temp equals to the elements, right? And then it's return the temp, right? And then we need to advance this too, which is current equals to current.get pointer. Then when it's being called again, it's going to get the next one, right? And advance it and return. Alright, so now we fix these. How about when we add them? This is the order list. So let's go back and look at the list for the add, right? So now let's say I have H J L Z. Z is not a good one because if I want to add at the end, I cannot test. Let me just say N then. Alright, this is an order list, and let's say we test, last time we test where we add at the beginning already, right? And we did the add in between and add at the end. So now let's test the code over again. Okay, so if I do G, I want to add G, so new node is G. Right, so we gotta look at the code at the same time. So we go down here, new node is G. We check if it is empty. No, it's not empty. Then we do else, right? So we said current pointer and previous pointer. Okay. So this is going to be your current, right? Because equals to LL. Because all of this is going to be previous, and this is LL, right? LL pointer, right? So it's pointing to the same location. While current not equals to null is not equals to null, then it's going to do this, right? So compare the elements, which is G to H. So G is less than H, right? Then yes, there's going to do if, right? Because after if compare. So now we can look, is this at the beginning or in between? Equals current. There you go. LL pointer is equals to current because they are pointing at the same. So this is the beginning. Then we say LL pointer equals to new node. Then we move LL pointer to new node. Alright. So now LL is pointing here, right? So this LL is going to be removed. No longer have this. Okay. And we didn't do else. New node.set pointer. I mean, we don't have to because we did if, right? True. And then new node.set pointer. So that means this new node is pointing to current, right? Because we have C right there. Correct? Once we're done, we say we break. So it's just exit the loop, right? Exit the loop. So let's go here to check if current equals to null. Current is not equal to null, it's pointing to there, right? Then it's not inserted at the end. So are we done yet? It looks like it's linked But one more thing that we have to take care of is the current and pointer. We have to reset them. Otherwise, when you use get next, it's going to be a problem, right? For the iterators. So we're going to, so depending on the location where we want to reset, if we have the iterator for, let's add that, right? Public E, like next, right? And public boolean has next, right? So in this case, you should reset your, after you add or remove, you should reset your pointer to the beginning, right? Then next we're taking care, right? Of a iterate from the beginning, right? But if you use with E here, okay, then we have to check if that element is existing. Now, since we're modifying that, we're going to have to add the unimplemented, right? At the end, right there. So this next, actually very similar code here, right? Then we have to reset our current. All right, after it breaks, it exit, and we want to move the current to where? RL pointer, right? So we're gonna reset that to where the RL pointer is to beginning of the list. Because current is like global to the class, when we call next, right, it will get from the beginning for you. Now for this, we have to say if we have to check is contains. Did we have contains? Yes, but we didn't finish that yet, right? We have to implement contains first, and gonna use contains, right? If it contains, then we start to do this, right? Or we gonna say if it's not contains, we throw exceptions, right? And then we never go down to the list to do. In that case, this one has to do throw exception, or we can do throw exception on contains, and contains we're taking care of exceptions. So we are most likely to need to create exception, because when we don't find a user, then we can throw exceptions, and we don't want to worry about how to handle it. We gotta let the views do the coding to see how they want it to look like with that message, right? So whenever there's exception, we'll just handle it. So throw user not found exception. They have user principal in the library. Alright, so we probably have to create that class where we put in the exception package. And extends from exception. So this is going to be very similar to this. So the constructor called super. Now at this point, then we said, hey, content should do. We come back to write the contents on linked list. So this content should do those, right? Throw user not found exception. Oops. We need to import that. So first, how do you know if the element is on the list? For example, we go use the same list. Now we have GHJLN. I'm looking for Mr. K. So it's going to add it to the list. Compare. That's why we implement dot equals, right? So when there's no dot equals, then not on the list, return false, right? Yeah, we may need to think about the location of who throw this. Like the code for content is we going to say current equals to LL pointer, right? Again, I said I'm looking for Mr. K. Now, this is being reset, right? They're all pointing to, after we add, they're all pointing to the same. If we're not adding, of course, we still want to set to make sure that current is going to point to the beginning, which is LL pointer. Right, so I said current equals to LL pointer at that point. And I start to iterate to this, just like when you do toString, right? So, like when you do toString, we have toString right here, right? While, right? So we gotta do that. While current not equals to null, we don't need to print out anything. We gotta move your current, right? And if we found, right, we have to compare if, right? Current dot. We can do the same, like use these first elements, right? Come first, which is, instead of using current go first, uses element, which is K, right? In this case, dot. We need to get, right? Oh no, sorry. Dot equals, but current has to get, right? Because current is giving you the user. Get element. Right. Now elements compared to elements. If equals, that means you found, right? So you're going to return true. One thing about doing this, you can return true or you can set boolean, like found equals to false, and then you just say found equals to true, right? And this is always return found, right? But once you found, you no longer need to iterate, so just break out the loop, right? So return. But while we search through a list, it never be equals, and current is at the end, return false. Then I don't see why we have to throw here, right? So the exception should actually throw